when you are solving equations that have radicals in them, one of the ways that you can go through and solve is to isolate the square root or the cube root or the fourth root, whatever you have. Isolate that on one side of the equal sign first. So if I take a look at what we have in this problem, there's a square root there, but outside of the square root, we do have a subtract 3. So for me to get started in this problem, I want to isolate the square root all by itself, and I want to take anything that's outside of the square root, put that over on the other side of the equal sign. So I'm going to add 3 on both sides. On the left side then we will have a 2x plus 3, and over on the right side we will have the square root, and now it is isolated. The only thing that is over on the right side of the equal sign is the square root. To get rid of a square root, we need to square both sides. When we square the left side, we have a binomial squared, so we want to think of that like a 2x plus 3 times another 2x plus 3, and then FOIL that out. And if you do that, you'll end up with a 4x squared plus 6x plus another 6x plus 9. Those are the 4 values you would get if you FOILed that out. And if we combine some like terms, we end up with 4x squared plus 12x plus 9 over here on the left side. And on the right side of our equal sign, if you square a square root, the square root and the square cancel, and you just get what's over on this right side, just what's inside the square root. So now what I have is I no longer have an equation with a radical in it. I now have something that is just a polynomial equation, and we go through and use our polynomial rules to go and solve this. There's a few different things that we could do. What I do see is that our highest power of x is an x squared, so this is a quadratic. So we could get 0 over here on the right side and then try to factor or use the quadratic formula to solve. That's what most people would do. So I'm going to take the 28x that's here, and I'd like to have 0 over on this side of the equal sign. So I'm going to subtract a 28x on both sides. In the next step, I'd like to subtract 29. If you are adding or subtracting 2 steps in a row, you could do those in one big step, like I did there. And now I do have 0 over on the right side of our equal sign. On the left side, we have 4x squared minus 16x minus 20. And again, from here you have a few different options you could go through. You could try to factor that or use the quadratic formula. Looks like maybe this will factor pretty easily. There is a common factor of 4 here. So if I factor a 4 out in front of all of those terms, we would have an x squared minus 4x minus 5. Factoring these 3 terms that are inside the parentheses, I'd be looking for 2 numbers that add to be -4 and multiply to be -5 times the invisible 1 in front of the x squared, which is a -5. There are 2 numbers that do that, -5 and 1. And because I have a 1 in front of the x squared, I am going to be able to go through and factor this using the shortcut. We have 3 things being multiplied together that equals 0. The zero product property says we can take each one of those and set those equal to 0. The first equation we really would have is 4 is equal to 0, which isn't true. It doesn't give us any solutions at all, so most people don't even write that one down. But anything with a variable we would want to write down and then solve. So, after isolating the radical and then getting rid of the radical, we see that there are 2 solutions. Except one of the things that makes this unique is when we go through and solve this whole process, these solutions are only possible solutions. They might be solutions, they might both work, Or maybe one of them works but the other one doesn't, or maybe neither one of these work and we end up with no solution. The reason that that's happening is because way back here in my second step, we squared both sides of the equal sign. And anytime you go through and do an algebraic step where you square both sides of the equal sign, then you may introduce extraneous solutions into the problem, and any solutions that you end up with at the very end are only possible solutions, and you need to take them and plug them back up into the original and make sure that they work. That process, though, is pretty fast and pretty easy. So one of our solutions down at the bottom was x is equal to 5. We want to check that. We want to see if x really does equal 5. So all I would do is take 5 and plug that in for the x's. I wouldn't do any calculating in that step. I would just write down the substitution. And then I would evaluate each side and see what we get. On the left we have 2 times 5, which is 10. And on the right side we have 28 times 5, which is 140. 140 plus 29 is 169. The square root of 169 is 13, and 13 minus 3 is 10. So we get 10 equals 10. That's a true statement. So definitely 5 is a solution. We also need to check, though, our other answer, which was a -1. So let's see if x is also a -1 or if 5 is our only solution. So again, just takes 2 steps. I'm going to plug -1 in for the x's in the original and then evaluate. Two times -1 is a -2. 28 times -1 is -28 plus 29 is 1. The square root of 1 is 1, and 1 minus 3 is -2. That is a true statement. So both of our original answers actually are solutions. But if all you do is write down that 5 and -1 are your 2 solutions, and you don't show your work by checking, you wouldn't get full credit on the problem. You have to go back and plug those numbers back in. Anytime that you raise both sides of your equal sign to an even power, you have to plug those numbers in. In this case, we squared both sides. So when we got to the bottom, we had 2 possible answers. And part of the work for this problem is to check and see if either or both or none of those end up being solutions. In this case, both of them did.